Hello, this is Eduardo Suarez. Today we're going to look at two particular data types in KAREL. One is called user-defined structure and the other one is called user-defined data type. When you are writing your program, you may find a situation where you need to create your own data types. In that case, KAREL has an instruction called structure that can help you with that. We're going to start by creating a new KAREL program. We're going to go to Files, New File, and KAREL Source. And we're going to add a few lines of code. And we're going to save it. Here we have the declaration section of the program. And between begin and end, we have the executed section of the program. In the declaration section of the program, we're going to write type. And this is going to create a new declaration section. Under this type declaration section, we can create the user-defined structure data types. And this is the only place in the program we can create the structures. Now we're going to create our first structure. We're going to give it a name, structure box, and we're going to use the instructions structure and at the end structure. And so everything that is included between the instructions structure and end structure will be the declaration of the user-defined structure. Now that we have created a structure, we're going to add some elements to the declaration of the structure. So what is a structure? A structure is basically a list of fields, each one of which can be a standard KAREL data type or another predefined user data type. Now we're going to add a new declaration section. In this case, we're going to use var, and this time we're going to declare a variable box that is type structure box. Next, we're going to go to the executed section of the program, and we're going to assign a value to each one of the elements of the variable box. You're going to notice that we can access each one of the fields of the structure by using a variable name, followed by a dot, and then the name of the field. Another way you can do the same without repeating the name of the variable, and that is by using the set of instructions using, do, and end using. In this case, we are omitting the name of the variable and just typing the name of the field. Now we're going to save this program and we're going to run it. Dependent. We're going to go to select. We're going to select the box definition and we're going to run it. Notice that apparently nothing happened, but actually the program was executed. While the program is selected, we can go to data, we select KAREL variables, And we can see here that for the box definition, we have the variable box that is type structure box, and we can see the fields of the structure by going inside the structure. And you can see that the values were assigned to each one of the fields of the structure as per the executed section of the program. If you cannot see the KAREL variables, go to Menu, Next, System, Variables, and go to the variable name KAREL enable and make sure that is set to 1. In summary, what we have done so far is we have declared a user-defined structure data type. We have declared a variable using this data type, and we have assigned values to each one of the elements of the variable. Now we're going to look at the things that we can do and we cannot do with the structures. We're going to create a new KAREL program. We're going to call it box definition 2. And what we can do now, we can reference the variable box from the KAREL program box definition. And in order to do that, we're going to use the instruction from box definition. Notice that we need to add this instruction in both the declaration of the structure and in the declaration of the variable. So what is going to happen now, if we change the values of the assignments for the assignment in the elements in box, these values are going to be changed in the original variable box from box definition. We're going to set this program, we're going to build it, and we're going to run it. We're going to go to select. We're going to select box definition 2. We're going to press shift forward. Again, looks like nothing has happened, but now we can go to the data. If we select box definition 2 and go to data, we're going to notice that the box definition 2 data is blank because actually the variable box belongs to the box definition program, and the only thing we are doing in box definition 2 is making a reference to that variable in box definition. So now if we go to box definition, we select the program, we do exactly the same, we go to data, we're going to have box structure box, and we go inside, and you're going to see that the box definition 2 program actually changed the value of the variable box in box definition. We're going to look at a few more examples. We're going to declare a new structure. We're going to call it a structure box, and we're going to declare a new variable box 2 that is type structure box. We're going to save it, and we're going to build it. Notice that now we have an error saying that the structure box is already defined. That means that we can use two structures with the same name in the same program, even though they belong to two different programs. What we can do is the following. We're going to delete the first structure box. We're going to comment out the from box definition, and we're going to change box to box 2. Now we're going to save the program, and we're going to build it. So now we're going to run the two programs again. We're going to go to the teach pendant. We're going to select box definition. We're going to run it. We're going to go to data, and the value that we have is 10 according to the program box definition. Now we're going to select box definition 2. We're going to run it. We're going to go to data, and we have the variable box 2 with the elements according to the executable section of the program. So that means that we can have two structures with the same name as long as they are in two different programs. Let's look at one more example. We're going to put back the structure box from box definition. We're going to change the name to structure box 2. We're going to remove the comment from box definition, and we're going to declare the variable box 2 as structure box 2. So let's see now if I can do an assignment like saying box 2 equal to box. That means we're going to assign box to box 2. We're going to save it, and we're going to build it. Now we get an error saying that both variables are incompatible. That means that even though structure box from box definition looks exactly the same as structure box 2, they are not exactly the same. They are not the same structure. So we cannot assign box to box 2. When I do that assignment, we need to go back to box definition, and we need to declare box 2 as structure box. We're going to save it, and we're going to build it, and we're going to go back to, we're going to delete this structure, and we're going to change box 2 as from box definition, and we're going to say that is type structure box. So we're going to save it, and we're going to build it. Now we're going to run both programs again. We're going to select box definition. We're going to go to data. We have the data for box. And if we select the data for box 2, the data is not initialized yet. If we want to initialize the data, we need to go to box definition 2 and run the program. So now if we select the data for box definition 2, there is no data there, and we can go back to box definition, and the data for box 2, we have the same value as the data for box. Now we're going to see one more thing that we can do with structures. We're going to go back to box definition, and we're going to move the assignment in the executed section to a routine. We're going to declare a routine called box data, and we're going to have a parameter box that is type user data structure box. We're going to move the assignment for from the executed section in the program to the executed section in the routine, and we're going to call the routine from the program, passing as an argument the variable box. You're going to notice a couple of things. First, this is a procedure routine, not a function routine, meaning that this routine doesn't return a value. And second, we are passing the argument box as a reference, meaning that the parameter shares the same memory location as the argument. Therefore, changing the value of the parameter changes the value of the corresponding argument. We're going to see how that works in a moment. If we want to pass the arguments as a value instead of as a reference, we will have to use additional parentheses. So we have to call the routine with a double parenthesis. In that case, changing the value of the parameter wouldn't change the value of the argument. One more time. We're going to save it, and we're going to build it, and we're going to run it to see the result. We're going to go to data, and as you can expect, we have the same result as if we have the assignment instead of the routine. We have the assignment inside the executed section of the program. This is going to apply in the same way if we do the same change on box definition 2. We're going to move the assignment from the declaration section of the program to a routine, and we're going to call the routine passing the argument box as a reference. We're going to save it, we're going to build it, and we're going to run it. If we go to data, we don't have any data there. But if we go to box definition and we look at the data now, we're going to have the assignment from box definition 2 in the subroutine. Still, we can do one more thing. We can define a structure that includes another predefined structure. Let's see how it works. We're going to go back to box definition, and we're going to change the program. And this time we're going to create a new structure position that has as an element the positions on the X, Y, and Z axis. Structure box and add this element to the structure is going to be the variable box position that is type structure position. And you can notice now that on the executable section, I'm using the set of instructions using do and using to eliminate the need of typing the name of the variable parameter box. We can simplify this one even more if I add in the using instruction the name of the variable box position. In this case, I can take this one out from here and just have the name of the elements of the structure position. We're going to save it and we're going to build it. Notice that we have an error, and this error is because we have changed the variable definition for the program. So we're going to go to the programs and we're going to delete them. We're going to take book definition. We're going to delete this one too. And now we're going to go back and build that again. And this time we don't have any errors. So we're going to select book definition. We're going to run it. And we're going to look at the data. This time you can see that I have the variable box, that it has the three elements as before for the structure box, and now it has an additional element that is box position, that is type structure position, and we can go inside and we can see the assignment for each one of the elements of the structure position. And this concludes my presentation for the structures. As you can see, it's very interesting, all the things that you can do, and it gives you a lot of flexibility for creating your own user data types. Now we're going to look at the user-defined data type. We're going to open book definition and we're going to create a new program. A user-defined data type is a data type that you define in terms of existing data types. We're going to declare the user-defined data type inside the declaration section of type, similar to what we have done for the declaration of the user-defined structures. In this example, I have declared two constant values, number of rows, number of columns. I have declared two user-defined data types. One is called box array 1, that is a one-dimensional array of the structure box. And I have another one that is box array 2, that is an array of box array 1. You can notice here that I have split up the declaration of box array 2 as an array of box array 1. This can also be done in another way, just putting everything together in one statement. In this case, what we can do, we just we can write box array 2 as an array of the structure box, and if the statement is too long, we can also break it down in several lines, but by using the continuation character ampersand. In the executed section of the program, we need to access each one of the elements of the array, and you have to be careful the order of the elements. In this example, the first element represents the row, as we have defined here, and the second element represents the columns. We're going to open the teach pendant, and we're going to delete the program and the variables, so we don't have any errors when we build the program. Now we're going to save it, and we're going to build it. And now we can run it. We're going to select box definition, we're going to run it, and we're going to go to the data. You can see here that the program box definition has a variable called box array that is type box array 2. Box array 2 is an array of 4 of box. Here we can see each one of the elements of the box array that is type box array 1, as we have defined here. And now we can go inside box array 1. That is going to be again an array of 5 of the structure box, and here we have each one of the elements of the structure box. So now we can go further inside, and we just can go to the structure box, and we're going to see that this has the elements length, width, height, and box position. That is also a user-defined structure, so we can go inside this one too and look at the elements of the structure for structure position. Now you can see that we are on the element 1, 1. That is the element that we did the assignment. If we go to any other element, let's say we go back, we are on box array 1 will be for row. We're going to go to the second dimension, that is going to be 2 for column 2. We go to the structure box, and the data hasn't been initialized yet because we haven't done any assignment. And this concludes the first part of the video. In the second part, we're going to put everything together with a practical application.